In the late 1970s, humanity launched one of the most ambitious exploration projects ever attempted. Two robotic spacecraft were sent into space with a mission unlike anything before it: to travel across the outer solar system and reveal worlds that had never been seen up close. Among them was Voyager 2, a machine built to venture farther than any explorer of its time. At launch, few people could have imagined how successful the mission would become. Engineers expected the spacecraft to operate for only a few years. Instead, it would continue working for decades, transforming our understanding of the solar system. As Voyager 2 traveled outward from the Sun, it began a remarkable tour of the giant planets. Its first major encounters revealed new details about massive worlds that had previously been little more than distant points of light. Powerful storms, complex atmospheres, and mysterious moons emerged in extraordinary detail. But some of the mission's most surprising discoveries were still ahead. When Voyager 2 arrived at Saturn, scientists expected to find elegant rings surrounding the planet. What they discovered was far more complicated. The rings were not simple structures. They contained waves, gaps, twists, and patterns that suggested constant motion and interaction. Instead of a static system, Saturn's rings appeared alive with activity. The spacecraft then continued toward one of the strangest planets in the solar system. Uranus presented a puzzle unlike any other world. Its rotation was dramatically tilted, causing the planet to appear as though it were rolling around the Sun on its side. Voyager 2 provided humanity's first close-up view of this distant ice giant. It discovered previously unknown moons, revealed additional rings, and mapped an environment unlike anything seen before. The spacecraft also examined the planet's unusual magnetic field, finding that it behaved very differently from those of Earth and the other giant planets. Each new observation raised fresh questions. How had Uranus become so tilted? Why was its magnetic field so unusual? What events shaped its history? The mission continued farther outward, carrying humanity's curiosity deeper into the darkness of space. Meanwhile, another moment from the Voyager program would become one of the most famous images ever captured. As one of the spacecraft looked back toward the inner solar system, Earth appeared as an incredibly tiny point of light suspended in the darkness. From billions of miles away, our entire world was reduced to a faint speck. The image offered a powerful reminder of how small our planet is compared with the vastness of space. Every city, every nation, every human story existed on that tiny point of light. For many people, it changed the way they viewed humanity's place in the universe. Yet Voyager 2's journey was far from over. Ahead lay the most distant major planet in the solar system and discoveries no spacecraft had ever made before. The mission had already exceeded expectations, but its greatest achievements were still waiting in the darkness beyond. After years of travel across the solar system, Voyager 2 finally arrived at Neptune, becoming the first spacecraft ever to visit the distant ice giant. The encounter revealed a world of extraordinary beauty and surprising activity. Scientists had expected a cold and relatively quiet planet. Instead, they found enormous storms moving through the atmosphere and winds among the fastest ever recorded in the solar system. Neptune proved that distance from the Sun did not necessarily mean inactivity. The spacecraft also explored Triton, Neptune's largest moon. What researchers discovered astonished them. Rather than being a frozen and lifeless world, Triton displayed signs of geological activity. Vast icy plains stretched across the surface, while material erupted from beneath the crust and rose into space. These findings suggested that even some of the coldest worlds in the solar system could be more dynamic than anyone expected. After completing its planetary tour, Voyager 2 entered a new phase of exploration. Its mission shifted from studying planets to investigating the frontier between our solar system and interstellar space. Year after year, the spacecraft continued traveling farther from Earth. Eventually, it crossed the outer boundary of the Sun's influence and entered the region between the stars. This achievement marked a historic milestone. For the first time, a human-made spacecraft was directly sampling the environment beyond the solar system. There, Voyager 2 detected subtle changes in the surrounding plasma, magnetic fields, and energetic particles. The data revealed that interstellar space was not an empty void. Instead, it was a complex environment filled with matter, energy, and structures that scientists were only beginning to understand. Keeping the spacecraft operational became increasingly difficult. Signals required many hours to travel between Earth and Voyager 2. Its power supply gradually weakened as decades passed. Mission controllers were forced to make difficult choices, turning off non-essential systems to conserve energy. Yet despite these challenges, the spacecraft continued sending valuable information home. Each transmission represented a triumph of engineering and persistence. Perhaps one of the most meaningful aspects of Voyager 2 is the message it carries. Attached to the spacecraft is a golden record containing sounds, greetings, music, and images representing life on Earth. It was designed as a message to the future, a symbol of humanity's desire to communicate, explore, and be remembered. Long after the spacecraft's instruments stop working, that record may continue drifting through the Milky Way for millions or even billions of years. Voyager 2's mission is about far more than science. It is a story about curiosity. It is proof that a small machine built on a distant planet can travel into regions no human has ever visited. Its discoveries have influenced generations of scientists, inspired future missions, and expanded humanity's understanding of the cosmos. One day, the spacecraft's final signal will arrive. The communication link will fall silent. But Voyager 2's journey will continue. It will travel endlessly through the darkness between the stars, carrying with it a message from Earth and a reminder of what humanity can accomplish when it dares to explore the unknown. Even after its voice fades, its legacy will endure as one of the greatest adventures in the history of space exploration.